Yes, up to
Wesley,
you.
quit dish galloping all over the.
Why don't you like their
place.
picture? You
No,
said they're.
I
stay with
brought
your
this
goddamn
up to
topic,
you.
Wesley.
No, I'm explaining the
No,
hypocrisy.
you're not explaining nothing. You don't
the
want
hypocrisy.
anything explained. You're not here for a discussion. You're here to stop
No,
the
I
discussion.
am.
No, you're not.
All I'm doing is
No,
I'm
you're
bringing
here
up
to
the
stop
discussion you would trust.
Can I just finish with him? Because I understand a little more like what he's saying. So
the new topic now for the third hour is gas pressure, who won at 52%. We got the new votes going up for the fourth hour, guys, so make sure you vote. But now it's gas pressure for this hour, so make sure to talk about gas pressure.
Yep. Where's your experiment showing that there is a firmament?
You don't need experiments. It's called natural law.
It's axiomatic again.
No, where's your experiment?
No volume of gas can exist in a volume without physical
containment.
How do you know it can't be another force? Like Flat said earlier. Flats,
how do you know it can't be another force? What force? What force would you suggest? Would
any other force
to contain a gas? Like what? Any other force?
I'm just doing what Flatsoy did earlier when he said about gravity. I'm just saying.
I asked you specific. I'm not asking you why you said so and so. So I mean, no, I ask you specifically what force.
Be careful, you might get Flats's channel strike.
What?
Oh, Flatsoid, you said this earlier. You said why can't it be another force?
This is total false equivalence, is it not?
Yeah.
No, you said because
I said first of all the context was built on premise of scientific method, okay?
Yeah, scientific
and
method.
Wait. And the scientific method, he was proposing a specific cause for a specific observed phenomena. And I said, how do you know something else could not cause that? Because you are not controlling your variables. You are not showing to have one independent manipulated variable. That's what the context was. Now you are saying, heck, guys, ignore natural law because you're a moron and tell me, could there be a different force? First of all, gas pressure requires a container. Okay?
Where does it say that? What law is that?
Every single gas law in existence. Gas behavior by itself requires
the law.
Yes.
I'm not familiar with this.
Okay.
What is gas pressure?
Hey, hold on a second.
Show me the example.
Hold on a second.
Gas pressure without container. Show me just one example.
I'm talking with Flats. What law says that gas has to have a container?
Every single one of them. Bring me one that doesn't.
Give Browning in motion. That's a good one.
Go ahead.
Browning motion just describes the motion of the molecule.
Yeah, exactly, Roger. You might want to stay out of this. Flatsoy, what law? No, that's fine.
Every single law. Can you bring me one that doesn't?
Show me one.
Well, Lusak's law. How's that?
Well, wait a second. What does it
say?
You keep asking to prove axioms. You keep wanting people to prove
what does that
axioms.
Law say?
No, you keep wanting people to prove axioms. Okay.
So you need him to white knight for you, Flats?
I don't need anything.
What law says it has to require
Lusak's law.
Okay, state it or show it. What's that law say?
He's pulling it up for you right now. Hold on.
That's the problem with those kind of guys because they always use reverse. They should provide for us example
of that's what all flat earthers do. They make
container, but they can't.
Science prove a globe, but they can't prove their own flat Earth.
Science. You don't even know what science is. Please stop bringing science up. We're not talking science here. We're talking natural law. Okay, can you see on the screen?
Yep.
What does it say?
Show me where that requires a container.
What the fuck do you think that black thing around it is?
Where in the law, Sav? I'm going to make this real easy for you because I
told you it's axiomatic.
Where in this law does it say about container?
Do you not understand? What do you not understand about axioms?
You can't read it.
What do you not understand about axiomatics?
Flats,
what do you not understand about axiomatics? Stop asking to prove a negative. You're the one.
How's that a negative?
Because you're the one that claims against the axiom.
No, you
claim that. Stop interrupting, Wesley.
Okay.
No, not just okay. Stop. Make a conscious effort to stop being a douche canoe. Okay?
Oh, come on, buddy. It's gonna be
all right. Now listen to me.
He said a funny word.
If I make a claim such as you have, You have to prove, yes, you have, because you are claiming that a containment of physical nature is not required for a volume of gas or gases.
Never said that.
Oh, okay, then you agree. Good for you. Now, welcome to
you made the positive. You made the positive claim that gas requires a container. How's that not a positive thing?
It's not a claim. It's axiomatic. What do you not understand about that?
Okay, where's what is axiomatic
Show me the axiom, Soft.
What does axiomatic mean, Wes?
That's what he used.
No, what does axiomatic mean? You obviously don't understand what it means.
You're making the positive claim.
No, it's not a claim.
Gas requires a container.
It's not a claim. It's an axiom, Wesley. What is
self-evident? Self-evident.
Good job. PJ knows what it means.
You don't.
We all do, dude.
You don't. You're the only one that's having problems with it, dude.
No, I'm not.
Obviously, you are.
Flatz's claim was that gas laws say that they must require containment, physical containment.
All gas laws. All gas laws.
Okay, where is it here?
I've got it on screen.
Flatz? Where is it?
Literally
Flatz?
got it on screen. You see that black cylinder-looking thing?
Do you know that's not part of the axiom? Do you know that's not part of the axiom?
Yes, it is.
It's literally part of it.
Okay, where does it say containment in Guy Lussac's law?
It's
mass and volume.
Where's the containment?
Where it says that the water has to be.
Fool.
This is real easy. Where is the
it's self-evident, Wesley. It's self-evident.
Nope. You don't get away with it.
Yup, it is.
Unquestionable.
Until you can produce a volume of gas or gases without a physical container, you're fucking wrong.
Okay, where's the physical containment for a cloud?
Just do it. Go against
Where's the physical containment for a cloud?
What are you talking about?
Clouds are already in the contained system.
Yeah. Where is the containment for a cloud?
It's a transition phase, fool.
It's literally going through a phase change.
It's a transition phase, fool, and it doesn't remain in its current state, does it? What happens to clouds, Wesley? What happens to clouds, Wesley?
So when they're in
transition state, what happens to clouds, Wesley? What happens to clouds, Wesley?
They float around.
They just float around. They don't dissipate.
Some of them do.
They don't condense into water.
You think every cloud? You think every cloud condenses?
All the clouds are all that stay there. They're just the same.
You think all the clouds condense into rain?
No new clouds are ever formed. How do clouds form?
What are clouds for? Did you just say that?
How do
they form?
Oh my gosh! What are clouds for?
How do they form?
How do they form, Wesley? Are you deaf too? He's not only blind, he's not only brain dead.
What are clouds for?
No. Wow. How do they form, Wesley?
Oh, you want me to teach you? Sure.
Yeah, go ahead. Let's do it.
Vapor pressure forming
vapor
together.
Pressure?
You're already wrong. You're already
wrong.
Oh, it's not vapor pressure. Okay.
No.
Go ahead. Teach me.
What is vapor pressure?
You don't know what vapor pressure is.
No.
What's vapor pressure, Wesley?
You don't?
No.
Go. What is vapor pressure?
Vapor pressure is the pressure of evaporated water.
Pressure on what?
On what? You don't know how to take barometric pressure readings?
Within a contained
barometer.
System?
You mean a container?
You have to have a contained system to have a barometric reading.
Okay, then how do I have high and low pressure systems?
Well, there's various different. There's various things that.
So I don't need to have containment for having different pressure containment.
You literally need containment for that.
You do have to have it for any kind of a gradient or anything.
How do high and low pressure
any pressure at all?
Okay, citation.
What are you talking about? Citation.
No.
You have the positive claim. No. You have the positive claim.
You're just saying
no, you're there again. Nope. Want me to prove a fucking axiom.
Fallacy of transferring the burden.
That's all you do is transfer the burden.
Nope.
Because you can't prove your ridiculous bullshit.
Can you quickly read this one screen for us, Wesley?
Yeah. Exerted by vapor in thermodynamic equilibrium with condensed phases, liquid and solid, at given temperature, it essentially indicates a liquid tendency to evaporate. What I just said.
Why didn't you read it on screen? Read what's on screen.
I just did.
No, you skipped over at a given temperature within a closed system, Wesley. Within a closed system, Wesley. Within a closed system, Wesley. within an
Where?
enclosed system, Wesley.
Right there, dude.
Vapor
in black
the
and
pressure
blue.
exerted by a vapor thermodynamic equilibrium with its condensed phases at a given temperature within a closed system.
There
It
you
essentially
go.
indicates
Yes,
What's
here
a
we go.
closed system?
You think that means it has to be actually physically closed with a
What the fuck
container?
do you think- How
Here
else
we
would
go.
you
What does
close
this
it?
say in closed system, Wesley?
This equilibrium is established in a closed container where the vapor cannot escape. Okay.
Bing, bing,
So how
bing,
do I
bing,
have?
bing.
How do I have? Wow!
Thank you
Wow!
for
The
playing,
top
Wesley.
left of this panel is so great. How do I have?
Dunning-Kruger. You
how do I have
literally the
vapor
epitome of
pressure?
Dunning-Kruger, man.
How do? Oh yeah,
So
now
first
you
of all,
use
you tell me.
Dunning-Kruger, right?
First of all, no. Last time you're the same. Remember the same
Calculus,
last time with
right?
the sun.
Calculus
You told me
flats.
last time you told me the
Calculus.
sun wasn't. It didn't change. I show you it changing. You said do it this way. It still
No,
shows
you
exactly
did.
what you said
I
didn't.
agree with. I
Bob
would agree with.
explains to you exactly what you said didn't. I just show you what you say it didn't, and you're reading exactly what you say
So
it
then
didn't.
how? Okay. So then how does vapor pressure form next to dry air?
What?
You don't. Oh, you don't understand it now. Play dumb.
No. I'm just wondering where you get the dry air next to the wet air. I mean,
Where you get the
probably
water
temperature.
Do you know what the
We get the
difference
vapor
between
pressure.
a cloud and not cloud is?
Where are you getting a vapor pressure?
Off the water.
So the water evaporated into the dry air, and it became a cloud. Correct?
Okay. So why is there a cloud next to clear air, Roger?
I think you should be asking yourself why the water went up and
why
not
is
down.
a cloud next to? Why is a cloud next to clear air?
It's in the same system.
Hey,
Why
I'm
does
telling
the
you,
water
Roger,
go
Just
up
like
and
you
down?
have, just like you can throw a leaf on a pond, it floats on a pond. You have a cloud that's in the same
is a
system of
leaf
the
a
air.
gas? Leaf is a gas now.
Is vapor a gas?
Yes. Why does it have
Water
pressure?
vapor. Water vapor is a gas,
It is part of a gas.
so it's going through phase change.
And
caused by temperature, right? Is that what it is?
and what's your point? Flats? Yeah, what's your point?
And it's in the same system, correct?
What's in the same
You
system?
asked me why is there water vapor pressure in the same system of dry gas?
Yeah.
Same system.
Why are they separate?
Both gas.
Why don't they equalize?
It's a dynamic system.
They will sooner or
They
later.
do. It's
No,
what we
they
call
don't.
weather,
Of course they will.
man.
It's
that's
a dynamic
what we
system.
call
It's
weather,
never
man.
changing.
It will eventually dissipate into the rest of the gases.
Wesley, why don't we get participation of clouds in
Participation
very dry
of clouds.
weather?
Participation?
No,
It's just rebuttal for your
participate.
stupid ideas.
Precipitation.
If
Yeah,
they
you
wouldn't
can't even use
equalize,
scientific
you would
terms.
have
Not
clouds all the
participation.
time. They would
This
never
guy is
disappear.
literally
The Dunning-Kruger of this
Participation.
guy.
Wesley, you
No.
literally deaf, blind, dumb. I don't know what's wrong with you,
You
man.
said participation. What does that mean?
Participation, not
Okay.
participation.
That's what you said first.
I never said participation.
Do you see
Go
what
ahead.
he does? Now he's going
Go
to
ahead.
get you off. He knows what the hell you meant. He knows what the hell you said. Now he's going to get off on the
Yeah,
distinction
because you guys don't
between two
understand
fucking
scientific
words
terms.
because it gets off the fact that he's a retard.
He
You
didn't
see?
even understand that acceleration was a derivative of velocity. He said, no, it's not.
I never
and
said
then he had
that.
to correct and change it.
So waiting for you, man.
Go ahead. What was the question?
Why doesn't clouds participate in dry weather?
Said it again.
It's how I pronounce things, dude. I'm not
It's his accent, dude. Dude, it's his
It's my
accent.
accent.
Gosh,
And it's not
you said it
participate.
again. All right, for a third time, I'll answer you now. I'll assume you mean precipitation when you can't say it.
Assume.
Yep.
Oh, okay, Wesley. You know, you're. Did somebody tell you that you were smart? Where did you ever get the idea that you were smart?
Smarter than you by watching?
No.
you.
Where did you get that idea that you're only smart to you? You're the
No.
only person that thinks that. You look like a complete retard the
My
whole time
employer.
you've been up here.
My employer
So,
thinks so.
I've got it up on screen, but I'm not going to put it up yet until Wesley actually answers us.
Okay, go ahead.
Why don't you get precipitation of
Good.
clouds in dry weather?
Because it hasn't got to the vapor pressure needed to condense.
False. Should I bring it up on screen for you?
Sure. I could be wrong.
Good. You're always wrong. It's not.
We've
Well,
noticed
everything
that.
so far.
if
Game is
we have-
calculus, man.
Okay, what does it say on screen?
Oh my gosh, there's not enough moisture in air. That is the vapor.
That's not what you
oh my
said.
gosh.
Is that what he said, guys?
No.
That's not what you said, Wesley.
What is vapor pressure? What is
Again,
vapor
I
pressure?
asked you
Came up with
specifically.
this idea.
I came up with vapor pressure.
You
Soft
came up with it.
2025.
You came up with it. Show me
No,
what
you
it
didn't
is.
say you
the
came
idea
up
of
with
vapor
You
pressure.
didn't say you came up with vapor pressure.
Yeah, he
You
did.
came up with trying to explain clouds using vapor pressure.
Right. When it gets dense enough, or i.e. more moisture in the air section that we're talking about, it will
Air
condense
section.
the rain.
What air section?
The cloud.
How can you ask me? Can you explain to us why water goes up and not down?
Why does water go? Say that one more time.
Why does the water go up and not down?
I actually don't know the reason for that. I'd have to look it up.
Because
I can
gravity
look it up.
doesn't exist. That's why.
Okay, then why do things go down?
Because they're
Because
heavier
it's
than
denser
air.
than the air around
Okay,
it.
okay. On flat Earth, why does water go up?
Because it
it's
follows
dense in the air.
thermodynamic law. There's enough energy in the gas through phase change that it goes up. You know when you boil a kettle?
And tell me how that doesn't work.
Wait, you know when you
Tell me.
you know
No.
You know
Hold
when
on.
you boil a
why doesn't that
kettle?
work on a globe?
You know
Why doesn't that
when
work
you
on a
boil
globe?
Wesley, you know when you boil a kettle, do you know why you get steam and the steam goes
No,
up?
that's a really good point, Flats. I
You
agree
know
with you.
why?
Why doesn't that work on flat Earth? I mean, on globe. Why doesn't that work on a globe?
Gravity
You have to
pulls
have a
things down
contained
apparently.
volume.
Oh wait, what about your buoyancy? Just
What about
disequilibrium.
buoyancy?
What about buoyancy?
Wait, you claim
What's that got to do with what we're talking about now?
Is water heavier than air? Is it denser than air? Sorry.
Of course.
Yeah, but
Okay, so then why doesn't
water
your
vapor is a gas phase change.
But is it denser than air, Flats? That's what I'm asking.
It has energy. It's moving with
Agreed.
energy.
Agreed. That works on both the flat Earth and the globe.
No, your gravity
Yeah,
is supposed to be pulling things down.
No, the energy, just like you said, that was a perfect way of explaining it. I agree.
Ah. So does gas have energy?
Of course, everything has energy.
And gas is less dense than the water vapor.
Gas is less than, of course.
So why is the gas not escaping, but the water vapor can escape?
Out of what? Escape out of what?
From your
From Earth.
gravitational field.
Because of the energy. Why does the water vapor escape out of your relative
Gas has more energy than water vapor. Did you not know that?
Gas has more energy. Okay, show me that. Citation, please. Gas has more energy than water vapor. Okay, let's see.
There we go.
I'm looking it up. Did you
Right
pull
back
it
to
up?
Goose-Eck's law. Yeah.
Okay. So what's your point?
Point is, you're a moron.
Where show me where it says gas has more energy than water vapor. Where's your citation? I thought you said you pulled it up.
What happens when you decrease pressure?
So you can't pull it up.
What happens when you decrease temperature? Come
It
on.
gets colder. It gets colder.
And then what happens to the pressure when you do that?
It gets less.
Okay. Same volume, correct?
If we're keeping it in the same volume, then yes.
Okay, now let's put water vapor inside that cylinder and we heat it up.
Okay.
What happens?
It gets excited and has energy and will move faster.
What happens to the water?
The water is a vapor, so it will expand.
Water isn't compressible, so water can't expand.
Oh my gosh. Water vapor. We're talking about water vapor.
I asked you about the
Please.
water. I asked you about the water.
We're not talking about water. We're talking about water vapor, right?
Water vapor still has water in it.
What's your point?
What happens to the water when you heat it too much up?
It gets more energy, and it will
becomes
expand.
a gas.
It already
there's
is a
no-
gas. Oh my gosh! Water vapor?
I'm trying to explain.
Oh
I'm
my
trying to
gosh!
explain. Water vapor
Holy
is
cow.
water vapor is literally going through a phase change.
It
Wesley.
has gone through a phase change.
Busy going through a phase
Has.
change.
There's no water vapor
Busy
in water.
moving into gas, Wesley.
Hey, where do you get water vapor? Do you actually get it in the water?
No, Wesley. The thing is, it's going
Good.
through phase change. What is the next state of that change?
Gas.
So there's no water once it's heated up enough, Wesley.
Yes, it becomes water vapor.
No, there's no water anymore. It has now become a gas.
Okay. So you're saying steam isn't gas?
Didn't say anything about steam, did I?
Phase.
No.
What is steam? What is steam?
A transitional phase.
Water vapor.
But then if water vapor is not, then how do we get rain then?
That's precipitation. It's precipitation. It's just my language, Wesley, okay?
I know, it's hilarious that you don't know what you're saying.
I
He
literally
does know
know
what
what I'm
he's saying.
saying.
Yeah, dude. He has a. It's,
Blah,
it's
blah,
I
what
have
he
to think
speaks.
about how to pronounce
No,
it.
blah blah
properly,
blah
okay?
blah blah. Precipitation. Yeah, he says it with an
Okay.
accent. That's all it is, dude. That's nothing else.
I know that.
So you-
I know that.
Then
So
why
I
are you
do know
making
what
a
I'm
big
saying
deal?
then.
Because I didn't
If-
know that the first 3 times you said it.
But it's
If-
still funny,
if
right? Yeah,
gas-
that's why you're
if-
laughing like a cow. Yeah.
Well, no, because
If-
he doesn't understand that acceleration is the derivative of velocity. It's the first
Stop
thing
saying
you
that
learn in
nonsense.
physics.
I said you worded it wrong. That's why it wasn't correct. Then
No,
you
that
reworded it and
is
say,
correct.
yes, that is correct. Because based on
Yes,
the context,
so
you were
don't say
wrong.
it's not
So
correct.
again, Wesley,
You
so
don't know
again,
calculus.
stop showing you are a dishonest punk like you're doing the whole night and
How?
actually have an honest conversation.
How
Because
am
we
I
always have to
dishonest?
scream over you because you cannot behave yourself. Now,
That's
again,
being dishonest.
based back to the actual gas pressure
Okay.
on Gay-Lussac's law, are you going to concede containment is required?
It does not say that anywhere in there. No.
It literally is on screen.
In Gay-Lussac's law, where does it say physical containment is required?
The
Yeah.
constant mass and volume.
So where's the physical container?
Well, how do you get a volume? How do you get a volume without a physical container, Wesley?
Cloud.
There
A
you
cloud
go
is
with the
in the containment
axiomatics
system.
right there again. You
Cloud.
you have like this intellectual. You're about
So
12
you're
years
saying
old.
nuh-uh.
You're,
So you're saying
no,
nuh-uh.
listen. No, it's not nuh-uh. You keep going to axiomatics and making that they're claims. How else is there to get a volume of a fluid without a physical container? What method would be used to obtain a volume of gas without physical containment? How would you do that?
Arm load.
Okay, please read on screen for us all again, Wesley, so I can again show you for the 10th time tonight you're
Yeah,
wrong.
show me
again.
where it says physical containment.
Read,
I'll wait
read,
for that. Okay.
read.
Right there.
Show me physical containment.
Read.
We're
Okay.
reading right there.
Gay-Lussac's law, which describes the relationship between pressure and temperature of a gas at constant volume, requires not a physical containment, but containment.
Whoa,
because
whoa.
the pressure increases.
Whoa. Why are you changing the words?
Where does it say physical containment? What I asked for.
Why are you changing the words? It doesn't
I
say
didn't.
requires not physical containment. It says requires containment. But read on, please.
Because the pressure increases due to temperature change would otherwise cause the gas to expand, invalidating the law. If the volume is not constant, the pressure change is not solely due to temperature. Okay, so
Ooh. So
Where's
how are you going to
physical-
have a constant
where's-
volume? Wait. How are you going to have a constant volume without a physical container?
okay, so why do you have to have constant volume now? All of a sudden, you're saying constant volume.
Do you know how an engine works?
Jesus, crime and that, like, bro.
Wait, what? Why? No, I'm asking you a question. Why is
You know
constant
how an
volume
engine works. You know how an engine works.
a gas engine?
Yes, obviously an engine with a piston engine.
Obviously, there's many different engines, but yes, I know how.
Well, we're talking about a combustion engine.
Generally, I know how a combustion engine works.
Great. So what happens when the cool air comes in and it heats up?
Do you know how they heat it up?
Yes.
How?
First,
With
answer the question. Don't reply
With what?
the question for the question.
With bang.
Sorry, he was talking over you. What with what do they heat it up?
Spark and fuel make kaboom. Heat up.
Nope.
Pressure increase.
Nope.
Yes.
You're wrong. You're wrong.
Please show me a combustion engine without spark. Go ahead and fuel.
No,
Go
you're
ahead
right.
and show me.
You're right, but it pressurizes it first to heat it up, and then
The cold air is denser. So guess what happens? It fills up, and then you have heating it up due to the kaboom in the spark and the
You're
fuel,
completely wrong.
and it heats up and causes extra
You're completely
energy. So it heats up and it moves faster,
Nope.
and the pressure increases. Wesley,
What
that's
happens
why
is
it
the
pushes
air
the-
enters.
That's
The
why
air
it
enters-
pushes the piston. Wait, that's why it pushes the piston, which then moves the conrod to move that little dinky car you're thinking of in your brain.
No, you're here. I'll
Not
teach you how it
no, not
works.
no. You're a moron. You
I'll teach you
literally
how it
have
works.
no idea what you're talking
No,
about. I can build an engine
Why
with
you
my
have
eyes
a
closed.
carburetor. This is why you have a carburetor or your fuel injection. What it does, gasoline does not burn.
Yep.
It doesn't burn. Gas vapors burn. And so what it does is it mixes that, it sprays it with the air,
Right.
and that's where the spark is ignited. And then because of that combustion, it heats up rapidly and expands rapidly, causing it to a little explosion, basically, that pushes the piston, which then runs against a camshaft, right?
You're right. Hey, Sav, what happens? What?
Oh, you're right,
when-
but I was wrong when saying exactly the same thing. So how's that work?
Sav, where does the air come in? When the cylinder is completely closed, or when it's open? When you have a large volume in the cylinder?
You literally have to open it to push air in. What dumb question is that? Okay, but anyway, back. Can you read what's on screen now, or should I read it for you? No,
Dude, you're so dishonest. You're so
what's dishonest.
How? How is he
projecting. Stop
dishonest?
Let me talk for a second.
Stop projecting. Okay, you know what? Since he's not going to read it, I'm going to read it for him. Wesley,
See,
I'm
you
reading
can't do
what's.
it.
I'm
See,
going to
he's
read on
running.
screen.
Holy,
I'm going to read on
Flat.
screen what's for you. I'm going to read what's on screen for you because you still
Flats, why are
don't
you
want
running
to.
from
accept.
your own question?
If the volume, the volume were not contained, an increase in temperature would cause the gas to expand, leading to a decrease in pressure. This expansion would counteract the pressure increase caused by the higher temperature, making the relationship unpredictable and invalidating the law. What was needed there? What was needed there? What was needed there? What was needed there to measure this pressure?
A volume of some kind, right? Maybe.
Yep,
A
a volume.
Container.
Yeah.
Container.
Not
What's
a physical
up,
one, no.
Sam? Good to see you.
So Flat. So it's a combustion
Physical
engine.
container.
The air comes in when the piston is open with the most.
Not a piston's not open. Valve is open.
Yes,
the valve is open, not a piston.
You don't understand that the chamber where the piston comes up is when the air flows in?
Wait. A piston is never open in an engine, man. If you have an open piston, you should get a new engine.
Working.
You would have no compression.
Oh my gosh.
Don't stop it
This is
looking,
Called a
top
valve, a stem
Look,
seal.
The chamber where
The
piston
cylinder?
goes in?
Are you talking about the cylinder?
Yes, but Flats doesn't
Okay.
understand that. The Flats doesn't understand that. So the chamber opens.
You said the piston
the
opens.
cylinder,
The cylinder never opens. The
The
valve
cylinder
opens.
opens.
The
when
valve
the piston
opens,
comes out of
exactly.
it, when the piston comes out of it, that
Piston
then
doesn't come out of the
whole
valve.
gas goes in.
The piston never
But it-
comes out of the cylinder.
It moves up and down in the
It stays in
cylinder.
the cylinder.
Holy cow!
Flat. We really
Piston
have
stays. How do you have pressure? Dude, do you know how pressure,
He
cylinder
brings up
pressure works?
combustion engines and then he top lefts it.
Wesley,
Wow.
are you retarded?
Yes,
No,
he
you
is.
are.
That's
Yeah.
a rhetorical question.
How are you going?
pull
Have you ever
the
blown a
piston-
head gasket before? Wait, Wesley, have you ever blown a head gasket before?
No.
Obviously, because you know what happens when you blow a head gasket. You know what happens when you blow. You know what happens when you blow a head gasket,
Dude,
Wesley.
You know how the gas.
Do you know what happens when
air
you blow a
pressure-
head gasket?
Dude, run.
Hey,
Run.
Do you
buddy.
have pressure in the cylinder when you blow a head gasket, Wesley?
Run, buddy. Can I
Hey,
Do
talk
you
about
have
Wesley.
pressure in the cylinder when you blow a head gasket, Wesley?
Can I answer your first question because you brought up
Do
combustion engines?
you
from
have
God
pressure
knows
in
why.
a cylinder when you blow a head gasket, Wesley? The answer is no.
Okay, so do you know how when an air enters the
You know
cylinder?
why? You know why?
So no.
Because it's no
That's
longer
so funny.
contained in
It's
the
so funny, Flats.
container.
Saab
You know
corrected
why?
you on how
Because it
combustion
keeps-
engines work.
You know why? Because it keeps with Gay-Lussac's law, like I was explaining to you. Oh
Show me
my
physical
word!
containment
Guess
in that
what?
law.
So you need containment for gas
Yes,
pressure.
I agree. I agree.
Oh,
Not
so you
physical,
do
though.
agree. So no go
Not
Earth.
physical?
Welcome to Flat Earth. Welcome to Flat Earth, Wesley.
Not physical.
Thank
Dude,
you.
you just read the whole citation yourself, Wesley, and it did say you have to have contained volume of gas in order for this to work to begin with.
The globe completely agrees with you, Roger.
Yeah, and gravity is not a container, by the way. I hate
Oh,
to
that's
tell
what you
that.
say.
This-
Okay, citation.
No, that,
That's
you
what it
prove
is.
it. Prove it, dude.
Citation.
Prove it.
I can
You
prove
gravity
it to you.
is.
Sure.
Go ahead.
Go look at the flat Earth balloons that they've sent up measuring barometric pressure.
Why?
Yeah, what's
Why are
that
you
gonna do?
stuttering while you're saying that, though?
Yeah.
How do you have any pressure at all, gradient or not, without physical containment? That requires, in order to have
Roger
any
knows.
pressure at all, as was stated in that law, in order to have any pressure at all, it has to be contained.
Roger knows. He just answered the question.
That's exactly what I would say. In order to develop pressurized you have to have containment to begin with. You have to have a contained volume of gas. That is the law, dude. Simple.
That's not a law.
Yes, it is.
Show me that law.
In order to gain any kind of pressurized system, you have to have containment. We just went through like
Show
two
me that
different
law.
laws.
Show me that law.
Okay.
You read it yourself, dude.
Can I say something?
It never said
Yeah,
physical.
go ahead,
Sam.
Sam.
Can I just say something? Hey, what's going on? Can you define what is madness? What is somebody that is mad, somebody that is mad, that is crazy? Can you define him?
Sounds like
How do you define someone that is crazy?
I'll tell you.
Yes.
I'll tell you madness. It's people that haven't been educated or done any science experiments teaching about science experiments. That's madness.
Really?
No, that's ignorance more. It's not madness.
I agree too. That is also ignorance. That's a good point.
By the way, I can answer the previous question, which is in the Horsehead Nebula, there is gas pressure.
Sure, there is. What's the pressure reading?
Excuse me, and it can be measured. We
Oh,
can
okay.
measure.
What's the measurement on it? What's the pressure?
Hey, calm down, Sav. Let her talk.
I'm curious. How did you determine that it's a gas?
Yeah.
How did you determine it's a gas? How did you determine its distance? And where did you get a pressure reading for this at?
By spectroscopy.
Spectroscopy.
Nope.
Spectroscopy.
Yes. Try again, Sav.
Spectroscopy.
Yeah.
So a
can you show us?
spectrometer
Let
is
me
that a
ask you a
container?
question. Here, just real quick question. If you went and had a blood test done, right, and the results came back and said that you had 40 weight motor oil for blood, would you believe the test because it would be impossible for you to have 40 weight motor oil for blood?
Why
or
is
would
it
you
impossible?
just believe the test because the test said that?
What's being violated? Why can't a nebula have pressure?
Right. Well, because you need you need containment for a volume of gas.
That's begging the question.
No, it's not begging the
Yes,
question.
it is.
That's
You're begging the question.
axiomatic. Brenda, that's axiomatic, sweetheart.
There's no axiom.
Yes.
There's axioms in math. There's no axioms in
Yes,
science.
there is. There is.
No, there isn't. No, there isn't.
Absolutely.
Can you
Absolutely. Look
before
up
we
the
go
word,
on,
Brenda.
What's
you
the
do us a
axiom?
favor?
Look up the
Before
word,
we-
Brett.
What's the axiom?
Before we go on, can Wesley do me a favor and read what's on screen again?
Wait, are you going to say that I disagree with this? I just want to know before I read it.
You've been fighting against it the whole time.
Yeah, you've been saying no.
When have I ever
containment.
said that a whenever I ever said that a combustion engine didn't require physical containment?
That's what you've been fighting against the whole time.
No, never. Never said anything. You brought up combustion.
Must be a
You brought
different
up
Wesley,
combustion.
guys. Maybe he's clone.
When did I say that?
Maybe it was his twin or clone in you.
Dishonest,
Something wrong
right?
with that.
Dishonest hypocrisy.
Something
I
wrong
never
with
said
I-
a combustion engine.
Am I lying, guys, or was he fighting against us the whole time?
A combustion engine requiring physical containment never came out of my mouth.
You said the piston was open.
When the piston slides out of the cylinder, I know it doesn't go all the way out, but it sucks
Oh,
in
so
the
it's still
cold air.
in the cylinder. Okay.
What happens to the rest of the cylinder when it moves to the forward position? It's still there, isn't it? So all
Right,
it's
and what
doing
happens
is
to the
moving-
gas?
Yeah, all
What
it's
happens to the
moving-
gas?
all it's doing is moving back and forth within the cylinder.
Agreed. But
It
Keith
gets pushed
didn't know
out through
that.
the other valve.
He thought the cold air had to be heated up by something else before it got
It is
put
heated
into
up
the...
by expansion. Why do you think?
By
Why do you think?
expansion? Did you just say
Expansion
the
cools.
air was heated by expansion?
Yeah,
Did you
expansion
just say
No,
that?
the expansion cools it down due to the heating up of the spark and fuel.
Right, expansion cools. You're right.
The hypergolic effect. It's a hypergolic effect that happens with a mixture of
Yes.
the gas vapor with
Pressure
the air.
gets...
Please show me how the
increases.
gas is going to expand. Please show me how the gas can expand if you don't have spark.
You simply
It does not.
pull out
Oh my God.
the piston.
The
It-
piston
what
No, it
expands.
doesn't expand.
What happens to it then?
Obviously,
What
these guys
happens to the
have
gas when the piston
never
slides
tried to
out?
build an engine before.
What
Yeah, I
happens when the
have.
piston slides out?
Well,
Flats can't answer it.
anybody on here that's actually built an engine, can you?
Me,
You can't
I have.
answer
Can
it.
you? Can you build?
I
Can you
have.
start an engine without spark?
No, you
We
can't.
never talked about that. Flats, what happens when the piston
I
pulls out
literally
of the cylinder?
told you this now, and you told me we never spoke about it.
No.
It was
If you
literally
have
my
a volume,
conversation.
if you have a
said the
volume of
expansion
gas,
heats up the air. You
The
said expansion
expansion of the gas
heats up the air.
comes from the heating up of the gas.
Okay.
yeah, the heating
I
comes
agree
from
with
the
that.
compression.
Yes, and the heat comes from the
How
compression.
are you going to move the
Exactly.
crankshaft to move the piston without the expansion of the gas from the heat?
You said that the air comes in cold,
Yes.
Yes.
Comes through the valve
and then
cold.
it gets compressed to heat it up.
No, it
No.
gets heated up to push
The
the
spark.
piston down, and then guess what? It cools down
Heating
again.
No.
doesn't push the piston
Oh
down.
my gosh,
Yes,
Flats,
it-
you're so
Yes, it
dumb.
does. It literally
No, it
pushes
doesn't.
the
So
piston.
dumb.
No. Heating
Oh,
like the gas
Expansion
doesn't push
gas
the
doesn't
piston
push a
down.
piston, guys.
The
Oh my
expansion of the
God.
gas does.
So dumb.
Yes, it does. Once you
No.
ignite
Oh
the
my
gas,
word! I
yes.
literally
But
build engines, and you tell me, oh my.
What do you take some such complicated examples? You know, I don't know about
I
engines.
don't
Because
know
they're
why he
trying
picked
to-
this.
I don't know about engines. Let me
Yes,
give you an example.
Sam,
and
that's why he picked it. I don't know why. He has no clue how they work.
it doesn't matter how it can be
Well, you
right
just
without
said why
knowing how
pick
it
such
works.
complicated examples.
Exactly.
You said
Let's take a very small, very
There you go.
simple example.
Oh
Do you
my
see
word!
that-
What's happening?
do you
What's
believe that-
happening?
You see how it pulls in and then it
Oh,
decompresses
when
the
it
air.
cools down, it pulls it in. When it heats up, it pushes it out. Oh my word! So it's doing exactly what I
What happens
said.
to the gas? Oh my
Oh
God.
no! Guess what, guys? Wesley's shown
Oh, my
wrong
gosh.
again. What's that? The
Another
12th
one.
time tonight?
Another
Yeah,
flatoid.
around the top of that piston, you see those things
None of
called
this-
rings there? Those rings actually keep the compression in the containment.
Mm.
Yeah, that's irrelevant.
Can you see where the
job.
valves?
No, it's not.
You see
Yeah, it
where the
is.
valves are opening. They have what they call spark plugs there. You know what the spark plugs do?
Is that what makes the spark
They
and go
ignite-
boom boom?
You know what the
spark
spark
plugs,
plugs do?
they ignite the
They
gas.
Spark
ignite
plugs
the
go
fuel
boom,
in
duh.
the cylinder, and it go
Right.
kaboom, and that kaboom heats the air, and it pushes the piston down.
So
Oh
do you
my
see
word!
when, do you see when
Then
the
it
gas
cools
comes in?
down, and guess what? The air rushes back out.
Do you see when the piston gets filled with air, it's pulling it in cold and then it compresses it to heat it up? Do you not
Is this guy-
understand that?
Is this guy literally retarded?
Not the explosion, let's just call it that, is pushing the piston down. The reason it goes back up is because it's on that crankshaft. The next one fires in sequence.
And what does it do to the air
by
pressure
going
in that?
down, it keeps the crankshaft going, but because the position where it's at, it keeps moving it back into position to be expanded again.
So what happens to the air when the piston is going up, pushing it up? What happens to the air?
The valve is
It goes out the valve. The other valve opens. The export valve opens. The exit valve. They got 2 valves per cylinder. You do know that.
What happens to the blue
In this
air?
case, you got 4 valves. In this case, you got 4 valves per cylinder.
Hey,
2 inlets and 2
what
outlets.
happens-
Why do you have
what
inlets
happens-
and outlet valves, Wes?
What happens to the cold air when the piston goes up in this picture?
It goes out the valve,
down.
dumbass.
No, it doesn't.
Yes,
the
it
export
does.
valve
It compresses
opens.
the air. Oh my gosh!
It compresses
Why
the
would you
air.
bring this up again?
It heats up. It gets compressed, and then the spark
Yes.
ignites it and goes through the cycle again.
This isn't that hard.
It doesn't go through the cycle again. It's new gas that come in, Brenda. It
That's
doesn't
what I said.
recycle
When
the
does
gas.
it come in,
I
Flats?
didn't
When?
say.
You said
I didn't
recycles
say
the
it.
gas.
The carburetor
That's
actually feeds gas into it. It becomes vapor, and then it doesn't. That's why you have to
So
burn
does
gas.
that blue air just magically appear in there? Does that blue
No,
air
it gets
just
sucked.
magically
It
appear?
gets sucked into
when
the
the
valve.
gas
It
expands, it
gets
cools
sucked in,
down.
and then it compresses.
Right. So,
It's not
so
Yes, but that
Flashlight-
doesn't ignite the gas and heats it up. Doesn't you can sit there
Agreed.
and just pump air
But it
into
makes
it? No,
more
it won't
compressed
work.
and hot. So it's better to
No,
ignite.
no, that's not what makes. That's what makes it not hot. The
That's
heat
a
comes
gas
from the
law.
spark.
That's a gas law.
Okay.
It's a
Let me
gas
ask
law.
you,
It
what
has to
happens
be
when
done.
you increase the volume? What happens when you increase the
Try
volume
doing
but
it
keep?
without a spark, dude.
Yeah. What
I
I
happens
never
when
will
said
you
you
say-
need a spark. Oh my god.
Wes,
you guys
what
are
happens
so-
when you increase the volume but keep the pressure the same?
When you increase the volume, it would cool down.
Oh, okay. So what
So
happens
what
when
happens
the
when you
piston is
compress it,
pushed down?
Flatzoid?
So what happens when the
you
piston?
compress it?
Hey, what happens when the piston is pushed down? Does the volume increase in the piston?
Yes.
So it
What happens
cools
when you push up on it?
down.
What
so
happens
it
when you push
cools
up on it?
down, Wesley. So it cools down, Wesley.
Okay, so what happens when you push up on it?
It gets hotter because the
good, you
volume is
got
going
there.
That's
down.
what we've been
But
saying.
guess what?
there.
Guess
That's
what?
what we've
Wait,
been
wait,
saying,
wait,
Flashlight.
Wesley.
I
You
taught
know
you
why I'm
about
calling you dumb.
calculus.
Wesley, you got to listen. You know why I'm calling you dumb?
No, hold
because
on
the
a second.
valves are open, so there is no pressure.
Yeah, that's
it's
the
pushed
cleaning-
out.
That's the cleaning stroke. Everybody knows that. That's the cleaning stroke.
Wesley is arguing that it is cooling down because you're making it smaller. It's heating up
No,
because
it's
you're
not.
making the volume smaller. It's
No, that
not.
was you. That was
I-
you,
I-
Flatzoid.
No, I never once said that.
Yes, you did. That's what
I
we've been
literally
arguing
said
against
you
you
got
the
an
whole
export.
time.
No, I said you got inlet
Alright.
and outlet valves. The outlet valves are
hope I'm not
open
too
when the
loud.
piston goes back up. So guess what? The volume doesn't change.
Before it
Volume-
ignites, it certainly does.
The
You
volume
absolutely
doesn't
do.
change. You know why it doesn't change, Wesley? Because there is no closed pressure in the cylinder. Why are we fighting about gas
Yes, there
in an
is.
engine? Oh, because Wesley and Brenda literally
Yes,
have
there is
never built an
closed
engine in their
pressure.
life before.
There's
Hey,
closed
I'm
Go
gonna
ahead,
let
pressure.
Sam.
Brenda.
Go ahead,
I'm gonna
Sam.
let Brenda take over, but
But
that,
well, you
you
don't
see
have
the
to.
blue arrow.
Go ahead,
you see
Sam.
the blue-
Go ahead,
You see
Sam.
the blue air. The blue air is being
Go ahead,
compressed
Sam.
before it goes.
Go ahead, Sam.
I just wanted to understand because I'm losing track. What's the argument here that there cannot be air pressure without containment? That's what
That's the
argument.
argument, yes.
Yeah.
Okay, so let me give you a very simple example, like a natural example. You know, when you fart, can you consider you fart as like, you know, a pressurized, you know, gas?
Are you asking me? Sure. Yeah.
Of course. Do you need a containment for that?
How does that prove that you
Wait,
require?
wait, hold on a second.
I
Wait,
just want
why would I wanna-
a question.
I agree, Glenn. We do agree. They're just too dumb to understand.
Pressure.
They
You need
don't
something
understand
to. You need the gas to push on something in order to be pressurized. If not,
No.
it's just there's no pressure. It's just, there
Brenda,
is-
let Wesley answer the question. Let Wesley answer. He asked
Roger,
Wesley
calm
the question.
down, buddy. It's gonna be
Yeah.
okay.
No, I'm
Yeah.
not upset at all, Wesley. I'm just saying,
Sound
to
upset.
keep it on
Sure
topic.
seems like it.
No, I'm not. No, you're
Okay.
actually avoiding the whole topic to begin with. In order to have a volume of gas, you have to have containment.
Hey,
This is the
well,
whole point to the whole
I want to
subject.
answer Sam's
No,
question.
no.
You can't
in order
prove
to
it.
have a
You
volume,
can't prove it, though.
I want to answer
You
Sam's
can't
question.
disprove it.
I want to be
Wait, you can't prove it while we're literally showing you an engine on screen that requires containment for gas pressure.
That proves
Welcome
that everything
to
needs a
reality.
physical container. That proves
Yes.
everything needs a physical container. Is that your level
Yes.
of science?
Wait.
This
You're
one
back,
example proves
you're
it
back
all.
to you're back to proof of an axiom. Sorry,
There's
Bart.
no
hold on a
axioms in
second.
science.
Yes.
Sam, I
Hold
wanna
on. Wait a
answer-
second. Yes,
Sam,
there
I
are.
wanna answer your
There are
question.
axioms,
Prove it.
Brenda.
Cite one.
Yes,
Cite
there are
one.
definitely
Well,
axioms.
that's one right there.
What's that?
You
Sam.
cannot have a specific volume of gas or gas.
You're
Yeah,
using
well,
one
citation.
example. to make-
Citation. Where's your citation?
Wait, Sam.
It's
I want to answer Sam's
self-evident.
question.
No,
Let
It's
me
that's
answer
not-
Sam's
no,
question.
it's
That's not how science works.
Brenda,
That's math.
Brenda, it's
Stop talking over Sam.
self-evident. It's self-evident. Okay.
Sam,
that's
it's
math,
to
self-evident.
not
answer your
science.
question.
I'm sorry
Sam,
to be
to
crude
answer
like
your
this, but it's simple. Yeah, go ahead.
Yeah, to answer your question, everybody here agrees that you need containment in order to have gas pressure. Okay.
Oh, yes.
difference-
Okay, no.
Now,
Let him
Nice.
speak. Let him speak. Let him speak. Yeah. Tell me.
Let's. See, this is where they jump ahead of the game and they can't be patient.
No, go
What
ahead,
we
go ahead,
don't
I'm
agree
listening.
with is that
Yes.
you don't actually need a physical, like a glass or a firmament
Yeah.
that you've never seen before to contain that pressure. We
So,
agree that you
okay.
need containment. We agree that you need containment. You need
Yeah.
some
What you
force.
suggest
to do
would
it.
be that containment that's not
Okay.
a
I got
physical
more
Right.
things for you to read. I got
Sorry,
more
guys.
things for you to read on
Question
screen than
from
Wesley.
Wes.
Go ahead,
Okay.
Sam.
How do
Now I
you
understand. It makes sense. It makes sense a little bit. That means you
Yeah.
agree that there is
Okay.
need containment. So,
Yeah,
what kind of containment is not physical? Do you have an example of non-physical
Gravity.
containment, like
Sure,
another gas?
gravity.
Something?
Or plasma or electromagnetics.
Yes,
Plasma is
all of those.
not a
Gravity,
phase change. It's not a gas
gravity-
anymore.
Okay.
Okay.
Question to Wes.
I'm saying use
I
plasma.
will start very slowly.
Plasma
is not a gas
questions.
anymore.
Do you have examples in
I wasn't
nature?
talking about the plasma being
Yes.
a gas flat.
Yes.
Stay with the
Gravity.
topic, buddy.
He's asking you for examples of
Do you have-
gas.
do you
should
have
I
an
think
example
saying
in
plasma?
No, he's asking
nature?
me for containers flat. Stay on topic.
All right.
No,
Well,
no,
can I add something to that list of containers then that are just as provable as the ones you've
So
suggested?
you say.
Okay, wait
So
a
you
second.
say.
Yeah,
Yeah, so
absolutely.
you say.
Absolutely. There is a council of magic elves that lives deep in the heart of the earth that determines these matters.
Yeah,
Now,
supernatural powers.
I have
Yep.
as much proof of that as you do of a plasma containing gas, or that there's
No, that's-
plasma around
Oh,
the
you
earth.
you
Okay.
you've written a scientific paper about
Okay,
these
I
elves doing
I
it.
don't need to write a scientific paper to
But
know
you said
that
you had
they're
as much
full of
evidence
shit.
as I had. You said you had as much evidence as I had.
I do.
Where's your
So where is your
citation?
evidence?
Where's your paper?
Where is your
Here's your experiment.
actual? Where is your actual experiment showing that the things that you actually propose as containment for a gas and causing pressure actually do? Where is yours? The same place my magic elf thesis is at.
Nowhere.
No, yours is unfalsifiable. Ours is falsifiable.
Maybe Brenda can read for us on what it says on screen, or Wesley.
I can't read it because in my browser it's all blurry. The resolution.
Okay. Would you be able to do it, Wesley?
Can you open the whole thing? Can you open the whole thing? Here's a more detailed explanation too.
Gas pressure requires a physical container.
Can you open the whole thing or not?
Because it arises from the collisions of gas molecules with the container's walls. Without a container, the gas molecules would disperse without creating measurable pressure on any specific surface. The container confines the gas, allowing these collisions to occur and generate force per unit area, which is pressure.
Now, can you go to the more detailed explanation so I can see that too?
Gases are comprised of particles, atoms,
need
or
you to
molecules
write it.
that move randomly at high speeds and have kinetic energy. These particles move in straight lines until they collide with each other
Can you
or
go
the
down to the
walls of
bottom?
the
We don't need you to read this.
container.
This is
Pressure
boring. Can you
as a
roll
result
down?
of collisions. When a gas is contained, the molecules collide with the walls, and each
Okay.
collision exerts a force on the
Now-
wall.
now
The
to
total
on
force
Earth.
exerted over the area of the wall constitutes the gas pressure.
He agrees about this.
Yeah.
The only thing is that he says it's not physical.
The gas is not confined. Its particles will simply disperse into the surrounding space, and there will be no defined area for the molecule collisions to create
Do you
a
agree?
measurable pressure.
Flats, do you agree that this is a good source? Google.
No. In that
Must
case,
I bring NASA
there's no
for you?
discussion. But
You trust
Oh, I'm asking you. Do you believe that's a good? Okay, you agree with NASA now?
Yeah, NASA is perfect.
Okay, why don't you like their
Container.
pictures?
There we go. There's NASA for
Why don't you
you.
like their pictures?
We don't take
I brought
everything.
NASA up for
Wesley,
you.
quit gish galloping all over the.
Why don't you
fucking
like their
place.
pictures? You
No,
said they're
I
stay
good.
on
brought
the
NASA
goddamn
up for
topic,
you.
Wesley.
No, I'm explaining the
No,
hypocrisy.
you're not explaining nothing. You don't
the
want
hypocrisy.
anything explained. You're not here for a discussion. You're here to stop
No,
the
I am.
discussion. No, you're not.
All I'm doing
No,
is
you're
bringing
here
up
to
the
stop
information
the
you would
discussion.
trust.
Can I just finish with him? Because I understand a little more like what he's saying. So he agrees about what we said. Just the only difference, if I understood correctly, is that he's saying that you don't need a physical containment.
Which you just read you do.
Please go back to the previous page.
You can have a
shocking fact
Sam finished. Janusz, stop talking over him.
That's the thing, Sam. If he's
can you give me
stop talking over Janusz? She was talking.
Wait, sorry guys. The thing is,
you
Sam,
give
if he agrees with us, Sam, then he has to agree physical containment.
No problem. Let me keep on, going into his head. So the thing is that now you're saying, okay, containment, yes, but not physical. All right.
Yep.
Now I don't know. I'm a very simple person. Can you give me an example of a non-physical containment that I can see in nature that surrounds me, not in the complex formulas of mathematics? Because
it's called gravity.
That you can see.
That we
Thank
can.
you,
In
Roger.
nature.
Yeah, sure. So a cloud. A cloud has higher pressure than the gas outside of it.
Thank you, Roger, for your super chat. Really appreciate it, man. Yeah, but what is the cloud held together with?
Wait a second.
Lower, thank you.
So the cloud can act as a containment for you. You're saying that it's possible that the cloud, the way it's made, it can form a containment somehow.
It has different pressure than the pressure next to it. Yeah.
A different pressure, but that means that it can contain a different gas, a different thing inside of it. Because we're talking about the containment here.
He just said that you can't have pressure without containment, and a cloud has different pressure than the air next to it.
But does the cloud stay in that exact volume?
That's not the question.
Well, wait a second.
Exactly.
Hold on a second.
Galloping soft.
The reason the clouds float in the air.
No? The cloud is water. It's like it's not water. It's like
water
vapor. No?
It's water vapor.
It's a kind of it's a kind of gas. It's a kind of gas.
Water vapor is gas. Yeah.
Hold on. What's it floating in? What is it floating in?
There are different kinds of gases. Not all the gases have the same density.
They have different gas pressures.
Yeah.
According to the law, they should all equalize.
They do, and it's called weather.
Is that pressure or is that density?
Please
is
listen.
That pressure or density?
If the cloud would be a container,
it's a gas.
as you
gas
claim,
does not have it has pressure. We call it pressure.
Okay. According to you, if the cloud is a container, it wouldn't change ever. It wouldn't equalize.
Wouldn't change ever,
That's
really?
not true.
Yes.
No.
Where do you get that from, Janusz? Where'd you learn that?
That's according to you. If the
I never said
cloud
that
would be a
once.
container, as you claim, clearly you did, it would never change.
I never said it doesn't change.
Well, what is the cloud in? What is the cloud floating in?
The atmosphere.
The atmosphere. So how do we have that atmosphere for that cloud to float in?
Because
in
of
the
gravity.
First place? Gravity.
Because of gravity.
Okay, what is gravity, Brenda?
Oh my gosh. Are you really going to go back to this?
It's mass attracting mass.
Why? Why does mass attract mass?
Doesn't matter.
Where does it get its
No.
energy from?
That's
Where
your
does it
claim.
get
You
its
must
energy
have
from?
found some mechanics behind it.
It's not been
If
proven.
you
No, we don't
claim
have
that,
to.
there must be some mechanics behind it.
Yeah.
What are the
Esau, where
mechanics
does it get its
behind
energy from?
We don't have to know. We don't know.
Yeah, we do have to know.
Why-
because
why do
of
we
the
have to know?
conservation of energy.
So
So
why do
if
we have
it-
to know?
So where are the mechanics involved with mass attracting
Don't know.
mass?
Don't know.
We don't know. Then how
Right,
do you
don't
know
know.
that that's actually what's going on? It's
Because we observe it going on.
It's
No,
testable.
well, wait a second.
It's testable
It's a-
and it's
Wait a
recreatable.
second. How do you know that it's because of the
Because
mass?
we can make observable, testable predictions.
But they're not always consistent. See, that's the
Yeah, they
problem.
are always consistent.
No.
They are consistent within a precision. Yeah.
But
Name
why?
one that's-
Why does so? Where does the energy come from?
What energy?
Why does the circle?
Well,
why
wait a
does
second.
Why does
If
the,
you-
why
does
does the
it take-
sun?
Hey, shut up, Wesley. I'm asking her something. You were the one just going on about people talking over somebody. Shut the fuck up yourself, okay? All right.
Okay, don't get
where
this.
if it
man.
takes energy to move something, is that correct? Yes.
Yes, it takes
Yeah,
energy.
it takes energy. Okay.
It takes.
So
Let me
where
reply
does
to.
the
Let me
energy
reply
Where does
to
the energy come
Let
from?
me reply to you. Let me
Okay.
reply to you. In a gravitational field, it takes energy to increase the distance between the two masses.
Well, wait
What
a second.
gravitational
though.
field?
It has to be producing an energy or converting energy from something in order to create this force.
Let's say you have a particle of gas between two masses, I'm sorry.
Well,
Strike that.
that's not what
Strike
I'm
that.
asking. Where did
I'm
the
trying to
energy
explain it
come
to you.
from?
Let me explain it to you. I fumbled up the first sentence. Imagine a particle of gas next to a large body, a massive body. It takes energy for that particle of gas to increase the distance between it and the large massive body.
Why?
Don't know.
Well, that's not an answer. I
inherent.
don't know.
Yeah, it is.
Yeah, there
You don't
has to
have
be.
to know everything.
Where is the energy coming from?
From the particle.
No, well, what you said it's the mass of this big object.
No, I said it takes energy to increase the distance.
Well, so what? Where's the energy from this mass coming from?
There's no energy involved in this.
Well, then how does it create gravity?
Gravity is a field in which takes
Well,
energy.
is it creative force?
Excuse me. I was halfway through responding to you. Gravity is a field, and in that field, it takes energy to increase the distance between the two masses.
Well, wait a second.
That's a belief.
That doesn't make any damn sense.
It's an observation.
That makes
No.
absolutely no sense.
It's a
Where is
testable,
the mass?
repeatable observation.
You're saying that the object itself, the larger mass, okay,
either mass.
Now wait a second, is going to cause the smaller mass to want to draw toward it. All right.
No. It requires energy for the to increase or to increase the distance between them. Whether that energy comes from
Don't you start out with them?
Whether that energy comes
mass, so how is possible?
Excuse me, whether that energy comes from mass 1 or mass 2, it doesn't matter, right? It requires energy.
Where is the mass getting its energy from?
What energy?
The energy it uses to create this gravitational field that you speak of.
We don't know that it takes energy to do that.
Well, of course it does, because if it requires energy to move an object, where is that energy coming from?
In general relativity, the mass alters space-time in such a way that yes.
I tell you something. You know what? You know what I've learned. I've learned that the more it's complicated, the most bullshit. Truth is very simple.
Your inability to
if you have
understand
to lose yourself into complex, explanations.
So let me sum it up.
With gibberish, it's
gibberish. It's gibberish. Let me sum it up for you.
You cannot understand it.
I know.
Let me speak.
We understand a lot.
Let me speak, please. Please speak. I want to sum it up. I'll sum it up for you. Under classical mechanics, right, you have two masses. It takes energy to increase the distance between them. And in general relativity, what happens is that the masses distort space-time around them in such a way that it requires energy for particles, right, to traverse that distance. Both are the same description, but they have sort of a different math behind them.
So
you didn't say nothing. You didn't say
1.5 minutes left of the topic,
it's
guys.
just some cockamamie.
So I want to expose the
equation. This is what you got is a cockamamie
equation
involving the warping of concepts.
No, stop. Why does the sun make circuits above your head?
I have no idea, because that's what God said.
That's okay for you, but not for Ben.
But it's not.
I have no clue.
Wait. It's not because I don't know. Why? It's not because I don't know it that you can say all kinds of madness, and we have to accept all the madness you're saying.
Well, you have
not
an argument, Sam.
Well, I asked you a question. What is madness? You never answered to me.
Yeah, we did. You agreed.
What
you said teaching physics? Teaching physics from people who've never taken a physics course in their life.
You forgot. I didn't agree. I told you it was ignorance. You forgot. So I'm reminding you. I never agreed it was madness. That's ignorance.
Sam.
Okay.
What is madness?
You guys.
Sam.
So,
I'm going to answer Sam's question.
Wait. I have to say the time is up for the hour. Now we are moving on to the new topic,